Good morning all. My name is B. Santhosh Kumar, Assistant Professor, Institute of Aeronautical Engineering. My subject is image processing. Today I am discussing about inverse filtering. So what is inverse filtering? Define inverse filtering. So the definition for the inverse filtering is that it is the process of receiving the input of a system from its output. That is the inverse filter. And it is the simplest approach to restore the original image once the degradation function is known. So how the inverse filtering is useful for image restoration? So in the inverse filtering, the restoration technique for deconvolution, that is image is blurred by known low pass filter, it is possible to recover the image by inverse filtering or generalized inverse filtering. So that is a process of inverse filtering. So inverse filtering is the process of receiving the input of a system from the output. So input to output, it is receiving the process from input and giving back to the output. And it is the simplest approach to restore the original image once the degradation function is known. Next, inverse filtering is how useful for the image restoration. So inverse filtering is a restoration technique for deconvolution. That is, when the image is blurred by a known low pass filter, it is possible to recover the image by inverse filtering or generalized inverse filtering. However, inverse filtering is very sensitive to additive noise, and inverse filtering is not regularly used in its original form. And another technique for inverse filtering is a pseudo inverse filtering. Pseudo inverse filtering is the modified version of the inverse filtering and stabilized inverse filter. The pseudo inverse filtering gives more better result than inverse filtering, but both inverse and pseudo inverse are sensitive to noise. So, however, inverse filtering is sensitive to additive noise. Why? And inverse filtering is not regularly used in its original form. So, what is the type of pseudo inverse filtering? What is the advantage? And how it is helpful to the inverse? So, pseudo inverse filter is the modified version of the inverse filter and stabilized inverse filter. The pseudo inverse filtering gives more better result than the inverse filter, but both inverse and pseudo inverse are sensitive to noise. So, suppose f of x comma y, it is the input image. Degraded output, then so we have to know three functions. F of x comma y is the input image. In the f of x comma y, if any noise is occurred, then here noisy image will be there. So if noise added, then what will happen of about g of x comma y? Noisy image. It is a noisy image. So g of x comma y is a noisy image. So after the f dash of x comma y, what is happening? It is the noiseless. That is original image. So it is the f dash of x comma y, that is a noiseless. So finally f dash of x comma y equal to f of x comma y, or f of x comma y equal to f dash of x comma y. It is the final value, final answer. So here what is happening in the inverse filtering means is better with inverse filtering. So pseudo inverse filtering is somewhat better with the inverse filtering, but finally the results are the sensitive to the noise. Both are using for reducing the noise. How it is good with with this one we will discuss. So the degradation comes in many forms such as motion blurring, noise and camera misfocus. In cases like motion blurring, it is possible to come up with a very good estimation of the actual blurring function and undo the blurring to restore the original image. So mathematical model for image degradation is the observation of g of x comma equal to f of x comma y into h of x comma y plus a of x comma y. Already we know that. So it is a estimating function image. So the degradation function, three principles are there. That is a observation, experimentation, and a mathematical modeling. So the degradation function h. So inverse filtering is a process of, here already we discussed inverse filtering. So inverse filtering is a process of receiving the input of a system from its output, and it is the simplest approach to restore the original image once the degradation function is known. Okay. So restoration is nothing but it is the original image. So that is the inverse filtering with the restoration. The inverse filtering is a restoration technique by deconvolution. When the image is blurred by a known low pass filter, it is possible to recover the original inverse filtering or inverse filtering. However, the inverse filtering is very sensitive to additive noise. So inverse filtering is very sensitive to additive noise. That is inverse filter. So a linearly spatial invariant degradation system of the additive noise can be modeled in spatial domain as the convolution of the degradation point. It is a point functioning. Now followed by the addition noise of noise or equivalently the frequency domain. The product of the Fourier transform of the image and the degradation is followed by the addition of ft of the noise addition and ft of the noise. So the solution is available for linearly spatially invariant degradation model. So it is one example of linearly degraded function, that is a estimating function. So it is a impulse function and it is a degradation function. So it is a image degradation g of x comma equal to h of f of x comma y plus nu of x comma y. So here g of x comma y is the output, h of x comma y is the degraded. Is a noise. So nu of x comma equal to 0 means it is there is no noise. No noise means g of x comma equal to capital H of f of x comma y. So if the noise is an additive noise, then capital H of f1 of x comma y plus f2 of x comma y equal to h of f1 of x comma y plus h of f2 of x comma y. If additive noise means f1 and f2, two functions added, f1 and f2. So if it is the homogeneity, capital H of a into f1 of x comma y equal to a into h of f1 of x comma y, and position invariant equal to g of x comma y equal to capital H of f of x comma y, and the capital H of f of x minus alpha comma y minus beta is equal to g of x minus alpha and y minus beta. It is the position invariant of the degradation function. So if the function is a linear position, then a linear spatially invariant degradation system with additive noise can be modeled, and a spatial domain convolution of the degradation, that is a point splitting function of the image. It is followed by the additive noise and addition of the noise, or equivalently the frequency domain. So furthermore, The recognition of position invariant, meaning that only one learned sample is needed to recognize the same gesture performed to another position in the gesture space. So, a set of gestures for a robo waiter was used to train gesture recognition algorithm. So, some gestures or recognitions are the important one in the position invariant of the degradation function. It is one example of linear space invariant image degradation function. F of x, y is equal to input image or input function degradation function. Nu is nothing but a noise. So for the input image f of x, y, degradation function is added with additive noise n of x, n of x. So output is a g of x, that is the output image. So it is a linear space invariant image degradation model. So we have considered the degraded output image g of x, y equal to h of x, y into f of x, y plus nu of x, y. Nu equal to noise. So the Fourier domain in the form of Fourier g of k comma l equal to h of k comma l into f of k comma l plus n of k comma l. So the multiplication is element wise in matrix vector form. H is W block circulate matrix and f comma g and nu are the vectors, that is a lexicographic ordering. So g of x comma equal to h of x comma y into f of x comma y plus nu of x comma y, and the Fourier function is g of k comma l equal to h of k comma l into f of k comma l plus n of k comma l. So these are the linear position invariant degradation functions. So these are the estimating functions with inverse filtering. So here inverse filtering is the process of receiving the input of the system from the output. So the simplest approach to restore the original image is the degradation function, and the inverse filtering is the useful of the image restoration. How the image restoration is means, inverse filtering is a restoration technique for deconvolution, the image blurring of the known low pass filter, the possible to recover the image by inverse filtering, and the generalized inverse filtering is the inverse filtering with very sensitive and additive noise. So a spatially invariant degradation system with additive noise can be modeled in spatial domain with degradation function of the image, and the addition of the noise means additive noise is equivalent in frequency domain, and the product of the Fourier transform of the image and the degradation is followed by the addition of the Fourier transform of the noise and the addition of the Fourier transform of the noiseless. And what is the solution is available for linear spatially invariant degradation model. It is a solution for estimating the degradation function and the image restoration. It is some examples of degradation images. These are the equation for degradation with additive noise, homogeneity and position invariant. It is a abbreviation for linear position invariant degradation, and it is the recognition of position invariant that the symbol is needed to recognize the same gesture performed at another position in the gestural space. And the gesture for a robot waiter was used to train the gesture of the recognition algorithm. So it is a function of f of x equal to h of x with g of x, and nu of x is the noise is added to the input function f of x. So h of x is a degradation function. So output g of x is equal to noisy. So after the removing the noise, that is the image restored. So that is a linear space invariant image degradation model. It is a equation of image degradation model g of x, y equal to h of x, y into f of x, y plus nu of x comma y. So it is a Fourier domain function. It is an image invariant and with Fourier transform equations. That is a small g equal to hf plus nu. Here already we know that g equal to output, degradation function, input function, noise. So it is about linear position invariant and inverse filtering. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.